Okay, this is the questions left over for the 6 to 8 paper that I haven't covered on the 5 to 7 before it. This question 18 onwards. So the first one. This is a question where it says the diagram shows two shapes that are mathematically similar. When they say similar, you can also think they are an enlargement. All lengths that you see are the same, have been multiplied by the same factor. So if we look at these two, this diagram, this one, you add a third of this to this one to go that way. So we're multiplying. So we've got 15 goes to 20, which simplifies to 4 to 3 as a ratio. The scale factor therefore is 4 over 3 multiplied by 4 over 3. Do the same thing for the bottom then. 4 over 3, where the smaller side was 6, this distance here must be 8. That's how you can do scaling. The alternative is to turn it into factors and work with the numbers. The problem you've got with this one is to say the shape k over 20 is an equivalent fraction to the distance that's equivalent to it, the 6, over its same shape, measurement, the 15. If you rearrange, we get k equals 20 times 6 divided by 15. I can pre-cancel 4 and 3 and 3 and 2, and I get the same answer, the 8. So this is using equivalent fractions, this is using ratio. Either technique's fine. Don't have to do both. I want to draw another shape that is mathematically similar to the ones in this diagram, but of different size. Give a length and a width of a shape I could draw. So it's got to be different. Effectively what you can do is choose any number here and multiply it by something else. So if I split this by 3 and multiply it by 5. So if I did a ratio 5 to 3, the 15 would become multiplied by 5, 25, the length, and the width of it would be 6 to some number. I'm doubling them to 10. You can do it with any number you like here, and as long as you multiply by the same things in both directions, I'm multiplying by 2 and multiplying by 5, as long as I multiply, you will get the right one. So I could do 6 to 3, doubling this one. That would give me multiply by 5, 6 to 5 would be 30 to 15. This one, doubling it, would be 12 to 6. And doubled both lengths. You could just double those numbers. Or you could double those numbers, 40 and 16. I would avoid doing the second one just because if that number's wrong, it could affect your answer here. So it's worth working back with the one diagram we know everything about. Next question. This is an equation of a line. This time they are actually talking about the intercepts and the gradients on it. I would like you to actually work out gradient intercept in this problem. So the diagram shows a straight line following this formula. Work out the coordinates of the points marked A and B. Well, A, we know, is where x is 0 and some y value. Remember, across first, up and down second, alphabetical order. So this point is 0, y. So x is 0 into this equation. Tells me that y equals 4 times 0 minus 2. Minus 2 times 4 is minus 8. So that's 0 minus 8. B is when y is 0. And that tells me 0 is equal to 4x minus 2. Well, I can divide everything by 4 or multiply it out. If you divide everything by 4, 0 divided by 4 is nothing, so we get x minus 2 equals 0. That's the case when x equals 2. So 2 and 0, because this point must be an x value and 0. Across, up and down, nothing. A different straight line has points 0, 0 and 3, 6. We'll go through it fully, although you probably might be able to in a moment we'll talk about there's one value you shouldn't have to work out. The thing to remember, gradient is the rise, the change in y, over the run, the change in x. Change in y, make sure you keep the order the same. So I'm going to start off with the 6, change in y is 6 minus the 0, divided by the change in x, well that's 3 minus 0, so my gradient is 2. That means I know the equation looks something like y equals 2x plus some number. I've got to work out what this number is. You might immediately know what it is because one of these points actually gives you this value. But the other way to solve it is put the number coordinates in that you know. So in this, if I use this one, y is 6, x is 3, so 2 times 3 into my equation, and that is equal to c. So c equals 6 minus 6 equals 0, and so the equation is y equals 2x. That plus that c equals 0 is actually that 0 there. If your x coordinate is 0, whatever this number is the intercept. And it doesn't matter what sort of equation it is, with the exception of 1 over somethings. This value is your equation. So this is effectively a plus 0 because of that one. Next question then. Next one. Box plots. You need to be able to interpret what these things mean. We'll quickly go through a recap as I describe them. Two groups of pupils collected a sample of acorns from the same tree. The box plots summarise the two sets of data. So group A, they got numbers between 21 and 31. That's what the ends of the whiskers are, the smallest value, largest value. The middle value is the median. So when all the numbers have been, the acorns are laid out in size order, this is the one that's in the middle. These two values are a quarter of the way along them. So if I had 40 items, there would be 10 in this section to this point, 10 in this section to the middle, 10 in this section to that point, and 10 in this section. Each of these lines represent a quarter of that group. So there's a quarter of the acorns are in here, a quarter of the acorns are in here, a quarter in here, and a quarter in here. Same thing for B. So explain how the box plots show the median of group B is 3 millimeters more than the median of group A. So the median is the middle line, sometimes referred to as Q2. And if we read the two values for group A, we're at 26. At group B, we're at 29. So now if I do 29 minus 26, group B is 3 millimeters more. You must show those two readings, preferably saying A and B, and preferably stating the middle is the median. You would probably get away with saying 29 minus 26. It's clear which numbers you are using. Although, no, be careful, because this one is also at 29. Be clear that you're talking about the middle line of B, because this has nothing to do with B. Which group has the bigger interquartile range? Now, interquartile range is talking about the distance between these two points, the ends of the boxes. So IQR is box width, and A, the box width is 29 minus 24, which is 5. Box B is 31 minus 27, which is 4. So the bigger interquartile range is A. That has an implication. Just check the next question. The results of the two groups are very different. Give reasons why the results might be different. Okay, so before we come on to this, this interquartile being bigger means there's greater variation. from their acorns. That's what the interquartile, bigger IQR range, interquartile range, is a greater variation in acorns. Whether or not that's good or bad depends on the situation. Generally, if you're trying to work with averages or find out a general rule, you would like that to be smaller, but you declare what it says as it is. So, greater variation of acorns. The results from the two groups are very different. Give reasons why the results might have been different. Now, first go back, and they have got them from the same tree. So what you now start thinking about is, what about this tree could be different, affect where the size of the acorns? Well, generally I would expect to see bigger acorns from nearer the top, because there's more sun. So we might get bigger acorns here because there's better sun to help them. And then the other two, they got those in the shade, so that maybe theirs are a little smaller. It might be the other way around. I don't know, not having done the. Might be the other way around. The smaller acorns might be at the top because they're further away from water, and the bigger ones at the bottom because they've got more water supply. I don't know which way it is, but what this indicates is they probably got them from different portions of the tree. One towards the top, or one of them on the sunny side, one of them on the shady side. Whether or not, which side is shadier and which one's not, you'd have to do the study yourself. So one reason, one group may have chosen shady side, and that's enough reason for one of them. Or maybe one group chose top or bottom. And what we're basically saying is they probably chose different parts of the tree. You only have to give either that statement, or they chose different parts of the tree. You do not have to go all three. Just choose one short statement for this. If you give too long waffling a statement, you may make a mistake and you may get penalised because of it. This is the last question on this video. We need to show that 4 times 10 to the 8 times 4 times 10 to the 4 is equal to 3.2 times 10 to the 13. The way to do multiplication of standard form, because that's what we're talking about, standard form, they actually say it at the top of the page, is you collect the numerators, the Mentius, the first part together, and we do 4 times 8, and then do the indices as a separate part of the calculation. 4 times 8 we know is 32, and when we multiply common numbers with a common base, we add the indices. So that will give me 10 to the 12. This is not in standard form though, because this number is not between 1 and up to, but not including 10. It's not in standard form. So if I want to make this into standard form, I need to make this number smaller by 10. Therefore make this bigger by 10. So we add 1 to that index. And therefore we get 3.2 times 10 to the 13 that they showed us. Do this calculation, write your answer in standard form. So again, I would write my divisions into fractions. And again, you can do the parts separately because we're doing a multiplication and division. They're equal precedence. So 4 divided by 8 I know is a half, which is 0.5. Now when I'm dividing indices, it's a common base, I subtract the indices. So 8 minus 4 is 4. So this is 10 to the 4. Again, this rule, it is not in the range from 1 to 10, so I need to make this bigger by a factor of 10, which means I must make this one smaller by a factor of 10, which reduces the index by 1. And that's those solutions.